Okay, so I am recording today. Trying. Been having recording issues. What? I'm recording today. So don't say anything else. Stupid. Okay, so the questions that we have been doing so far, I would say are below test level. Okay? Below. So what we're gonna do today is advance this a little bit farther. I have some of these printed out for you, and some of them I will. I gotta think about this just a second. Some of them, we'll see. We'll see what we do here.
All of my classes are small, but like one.
Very good catch. That's how mine is too. I have like 14 kids in all my classes except for my third hour, which has like 40.
English is a full class,
Yeah,
and then
that's what mine is.
every other class is like 14.
That's how mine is too. My English classes and the rest of my classes
Like
are.
last semester, all my classes were full but one. Last semester.
Okay.
Like I'm talking like almost all of Mr. Right.
Yeah, I know. It's huge. 3 hours.
We have 14 kids.
These are two hours.
Yeah, and my
Yeah.
it's been fun.
So these are Did you miss one by this one?
Okay.
A
A lot of words.
lot of words, but this you so you don't have to write them down.
I'm gonna just highlight
Which
the
one is
numbers and then I'll just go off.
Uh,
I see 2 degrees.
So listen. The thing, I'm not asking you to do these on your own, okay? We're working our way through these because this is what instruction looks like. So Grayson said, I see 2 degrees.
So we
The
can find
thing
the
with-
third one.
The thing with these kind of questions is they probably will involve 2 triangles and you will have to figure out what to do. This is what makes them more difficult than the other one. So again, I would say to you that I recommend that you draw the picture. Okay, so you've got, here's your skyscraper. There it is. I'm pretty sure that's like the Sears Tower. 780 feet tall. Here's your friend. Okay, here's you. Because it says you're a block away from a skyscraper that's that tall. Your friend is between the skyscraper and yourself. So this is your friend. This is you. It's the same skyscraper, but it's okay to have 2 different pictures. I like mine in the same one to start so that I can figure out what I got going on. So your angle of elevation, the angle of elevation from your position, angle of elevation, horizontal and up. Your angle of elevation is 42 degrees, not depression. Your angle of elevation for your friend, so horizontal and up for your friend, is 71 degrees. Yes. Okay, so I'm just going to make my triangles 2 different colors there and call that good. We would like to know, to the nearest foot, how far are you from your friend? So the thing that we're looking for is this distance here. Okay, so my question to you is, what do you need to do?
Find the distance from the skyscraper.
Yes, if you find the horizontal distance for both of them, one for you, one for your friend, then you have enough information to figure out how far apart you are.
Oh, wait, I'm kind of stupid.
Okay, so sometimes I like to draw these and then I will put the triangle, I'll pull them apart so that I can see what I've got. So there's your triangle. Here's your friend's triangle. 180 and 71. If I'm looking for horizontals, what do I have to use? 780. Oh, you're doing the answer. If I'm looking for horizontals, do I need to use sine, cosine, or tangent? Tangent. Trevor. Okay. Okay, I have the opposite. I'm looking for the adjacent. So tangent of 42 equals 780 over x. Okay, I know I've said this before, but I do have a couple absent people that I've been having recording issues. So remember, how can you solve this quickly? Swap those two things. So this very quickly, these swap, and you have 780 over tangent 42. Another one is going to be 780 over tangent 71. Because tangent 71 equals 780 over x. Okay, so this, your distance here in the 42-degree triangle, how far are you from the skyscraper? Yep, 866.28 feet. And then your friend is 268.58 feet. So if your distance, the whole distance here is 866 and some change, and this is 268 and some change, what do you got to do to figure out how far apart you are? Yeah, subtract those. 597. So 597.7. It does say this, though, to the nearest foot. So to the nearest foot, how far apart are you? 598. Yep, 598 feet. Okay, so when we talk about more complex questions, it's just that it's going to involve two triangles. Okay, so somehow interrelated with each other. Let's do number 2. Just like I'm thinking hot air balloon when I said a balloon flying at 3,000 feet because somebody's in it. Let me talk to you real quick a second. This is going to help with this question. Let me talk to you real quick about the physics of, that made that sound really fancy, but the physics of things that you're looking at. Okay, so if you're looking at something, Grayson, if you're looking at something far away, think horizontal, but you're looking at something very far away, how far do you have to tip your head to look down at it? Not very far. So my example of my warm-up where there's a 4-degree angle of depression, you're far away from that car and you're like, it's just not very far that you have to drop your ass. But if I was looking at something on the ground in front of me, what's the angle of depression there? It's steep, right? It's like if I was looking at Kira's feet as opposed to something out on the road out there, if I could see that, like it's a steeper angle of depression. Same thing is true about angle of elevation. If you're standing close to something and you're looking up, you're going to have to look up far as opposed to if you're standing back and you're looking up at something, you're not going to have to look up. So when you see on this one, the angle of depression to each end of the island, if it's 15.6, you're looking farther away than if it is 75.6, 75.8. It's going to help you figure out what you're drawing if you think about, am I looking far away? Am I looking close together? So I've got a hot air balloon, which I cannot draw. They look like light bulbs when I draw them. Whatever. Hot air balloon. See, this is terrible. I'm not redrawing it. Okay, so he's 3,000 feet above the ocean. Here's the ocean, and he's looking at an island. Okay, so here's my island with a palm tree on it. Some coconuts. Okay, that's a big island, actually. So it says the angle of depression directly in front of the balloon, blah, blah, blah. So angle of depression is horizontal and down. So he's measuring each end of the island. So you've got one that looks like that, which is obviously the smaller angle. And then you've got one that looks like this, horizontal, and then down to this end of the island. Okay, so this guy is the 75.8 and the other one is the 15.6. Okay, do notice you are talking about the nearest tenth of a mile on this one. So we know our vertical distance is 3,000 because those things are parallel. The vertical is vertical. So are we using sine, cosine, or tangent? Okay, so this is what our triangle looks like. Right, so 75.8 and 3,000. This is opposite. If I'm talking about the length of the island, I'm working on horizontals here, friends. So I need adjacent here. So I need tangent, correct? So tangent 75.8 equals opposite over the long way, and then tangent 15.6 equals 3,000 over x. Tangent 75.8. So this one, I got this distance to be 759.1. No.
I see where you try to throw us off for this question.
This one is the whole distance here is 1074.79. Okay, so how long is the island? So I got 9985.676. So how do you figure out how many miles that is? Divided by 5280. It's not actually a super big island. It's 1.9 miles. Okay. I am tired of doing tangents, so these are a lot of tangents. So let's talk, I'm going to switch gears here and tell you a different story. So just scribble these out. You'll want the space to work. You don't have to write this down if you don't want to. Just draw the picture. So yesterday and the day before, we talked about being a park ranger. And then you moved to being a lighthouse keeper, right? Yeah. Park ranger because we were fire spotting. Yes, my sparks with the fire, which you all didn't like. And then we went to being a sniper. Okay. So we're moving on. We're moving up the ladder, and you decide that, or you get promoted into the Secret Service. Okay. Very exciting. So somebody kidnaps.
The Venezuelan dictator?
I was gonna say the president's dog. You're not very up in the Secret Service ranks right now. You're just chasing the president's dog, holding the president's dog for ransom.
But if I get this president's dog, I'm promoted.
Yep. So.
We kill the guy who took the dog.
Or what if we just do
Okay, so you have tracked the dog. track the dog, the kidnappers, the dog nappers, stash the dog in a cave. It's a cave. Here's the dog.
Yeah.
There you go. Looks like sheep, but that's okay. Okay. There's a dog. They stashed the dog in a cave, and you, unfortunately, are on this side of the river.
Bro, he's in an index inside of the cliff.
It's a cave!
That's not a cave.
It's a cave.
Barely big enough to fit.
Shut up. Okay. Cannot get across the river because it's too dangerous.
How did he get in there?
Someone stashed it.
Somebody stashed him in there. Not my problem. You are just tracking him down.
What a dog. Look at this thing.
Okay, so
I think we should be concerned of why it's stashed in there.
that's what kidnappers do. Dog nappers. You just gotta rescue him. Doesn't matter. So here's the problem. You
Oh.
or the Secret Service, whatever. You're talking to your colleague on the other side of the cliff, who needs to know how much rope he needs. Okay, got to get down to get the president's dog and get back up.
Like a couple of days.
Okay, so here's what you know. You know that your angle of elevation to the other agent
We got oppression and depression.
he did say oppression. The angle of oppression. I appreciate that a lot. The angle of elevation to the agent is
What's the one that goes when you look up?
Elevation.
Elevation.
yeah. The angle of elevation to the agent is let's go 25 degrees. And you know, because you have your rangefinder, you also know that the line of sight to that agent is let's go 350 feet. Your angle of depression to the dog
350 degrees.
Where'd you pull that out?
what? 350?
No, I'm talking to Devon.
Because I put a degrees there.
Degree sign. Angle to the dog.
Angle of depression to the dog is
75.
no, I don't like that. 34 degrees.
Here's where it is.
And the line of sight
700.
is 430 feet, not degrees. Okay. Yep. So, how much rope does he need? So actually, let's go this, because if you actually do any rope climbing, you need a lot more rope than there is vertical distance. So, but you got to know the vertical distance. So what's the vertical distance to the dog? Okay, vertical distance to the dog.
Is that opposite over hypotenuse sign?
I don't know, is it?
If you just say like 3,000 feet of rope, I think you'll be.
No, you got to know vertical distance.
I know.
Yeah, because it depends on the kind of equipment that you get, how tall that you're up, how far you have to rappel down. Depends on the kind of equipment you you gotta know it, Devon.
So if I just
So
told
like
him
that
3,000 feet of rope, he drops
This
it
is
down.
why you are not
He
gonna be
says,
Secret
does
Service.
it reach? I say, yes, that's good. That's really good, actually. And then he goes back, gets everything to make sure we can actually get down there.
Because so remember that angle of they're always deal with horizontal lines. There's one angle.
What?
Your other. You with me? Okay, so Jason's gonna give you width of the river. Look, here's, I'm gonna. Look.
That's what mine are.
Yes, so you've got horizontal, here's your angle of elevation, here's your angle of depression.
Yeah, I heard that. Whoa.
So no, this is the dog, so you don't want to. You're here, so horizontal depends on your, okay, so here's your angle of depression. Your angle of elevation.
So.
You're looking at your other agent.
You gotta find.
You're looking at
you
both.
see the vertical distance.
So you're not our other agent up there?
I can see the other agent.
Okay. You cannot, just a second, you cannot cross the river. I could put some alligators in there, so that'll make you happy, or maybe some sharks.
How about we just like
Yeah, you're looking at,
What if I have a bow distance here?
yes,
Can't use a boat to get across spikes.
but we don't have enough information to do it in one, because this is not a right triangle. So you would have to do it in two, so 350 is your line of sight here, 350 is your line of sight
You
here
couldn't
to
get
the other
across the
agent.
water, so I was like, alright. Is that right?
I don't know that.
Oh, okay.
Draw a picture.
How do you draw?
Oh, I don't draw the picture, it's gonna hurt you, Trevor.
Do I add those two things?
I don't know, do you?
Do I? Well, that's why I'm asking, because I don't know.
Okay, so
You don't know, we have a bigger problem.
I'm not gonna answer the easy question for you. Okay, so here's what I want to tell you on this one. You guys, the key on this is horizontal. So if we're talking about your angle of elevation and your angle of depression, the horizontal has to be based on you. So your angle of elevation to this agent who is on the cliff up there is 25 degrees. On your line of sight is 350 feet. Your angle of depression to the dog, so from horizontal and down, is 34 degrees, and your line of sight is 430 degrees. You need to know the vertical distance from the agent up here to the dog. But there's no way, like if I were to pull these things out, so watch this, if I were to just pull out the big triangle there, this is 59 degrees, this is 350 feet, this is 430 feet, and I can't find this because it's not a right triangle. So I have to have split it into two right triangles that I know the information of. That's why horizontal is important. Okay, so you have to find this side and this side of this triangle, which you have to use what to do? Sine, cosine, or tangent. Yes, because opposite and hypotenuse. You have opposite and hypotenuse in both of them. So sine of 25 is opposite over 350. Sine of 34 is y over 430. So 350 times sine of 25. This one is 147.9 feet. This one is 240.45 feet. So if I want to know the vertical distance from this agent to the dog, this answers Javon's question. What do I do with those? You add them together. So drawing the picture, as much as some of you resist it, like it helps you figure out what do you do with those numbers. Okay, just like drawing this picture, you go, oh yeah, if I know this one and this one, I can subtract them and get that. This one, you go, I have to add them. So it is 300 and something. Yep. So the answer, the vertical distance from the to the dog is 388.4-ish feet. Okay, turn it over. We're going to do 5 and 7, and these are more difficult. So I need you to draw the picture. Okay? Draw the picture. Make sure you're paying attention.
A fly calculates the angle of depression of the base of an 8-foot wall.
Okay, so
Alive for like 2 days.
be quiet. Okay, so there's your fly, there's your horizontal wall, and this is 8. Now, again, the important thing is horizontal. So we're working from the fly's perspective. So the first thing you should be doing is drawing in the horizontal. Okay, so angle of depression, which is horizontal and down, is 33.7. Angle of elevation, which is horizontal and up, is 12.5. Okay, now this 8 is the whole length of the wall. Okay, we are looking for the horizontal distance that the fly is from the wall. So I'm going to label this as H because it's horizontal. Now, first question I need to know before we go any farther. Do you have any questions about the picture and why it's drawn the way it's drawn? Because if you can't draw the picture, this is complex enough that if you can't draw the picture, you're going to be screwed. Okay, now this appears, well, it doesn't appear. This has a problem. What's the problem? You don't know any individual side lengths. Okay, you don't know any individual side lengths. And so when you have that problem, it feels like there's not enough information. So what you have to do is a little bit of manipulation. This, I'm going to just make up a variable. I'm going to use X because X is a variable you use, and I'm going to make this, okay? It's some distance. I don't know what distance it is, but it's going to be the distance of X, and it's from here to here in this triangle. Okay, now, what's the top adjacent side over there? It's abstract. It's not a number. Thank you for telling me. Trevor said he hates doing this. This guy is 8 minus X. Because, right, just think about this. Let's put it in terms of something real. If this was 2 feet, how tall would the top one be? It would be 6, right? If this was 3 feet, this would be 5 feet. It's whatever 8 minus whatever the bottom is. So this guy up here is 8 minus X.
I know this, but I don't remember how to do it.
Oh, I don't think you know this. Okay, so if I look at this triangle without anything else, I have an opposite side and an adjacent side. So what does that suggest? Okay, so we have tangent of 12.5 is equal to 8 minus X over H. Okay, now in the bottom one, so ignore the other triangle, we have what 2 sides? Opposite and adjacent again. So this time we have tangent of 33.7 is equal to what? Now, this gets into solving a system of equations. Oh, so what I would do, you either need to get the X's by themselves or the H's by themselves, which is going to be easier. Correct, because you can just switch, right? So let's switch these guys and switch these guys. So we have H equals 8 minus X over tangent of 12.5, and H equals X over tangent 33.7. Now, if we know, yes, because if these are both equal to H, then they're equal to each other. So if you're like, this is going to be terrible, tangent of 12.5 and tangent of 33.7 are numbers. Put them in your calculator and turn them into numbers and make your life a little bit easier. Okay, so I'm going to do that actually. Tangent of 12.5 is 0.222. And tangent of 33.7 is 0.667. Okay, now there's a little bit, this now has turned into just an advanced algebra question. Okay, the trigonometry is gone. How do you solve two fractions equal to each other? Yeah, you cross multiply, which is Band-Aids, if you remember that from middle school or algebra class. Okay, so this is 0.222x, and this is equal to 0.667 times 8 minus x. Don't forget to put parentheses around the 8 minus x because this does involve some distribution. Okay, how do we solve this? We did this when we were doing logs, so we've solved these recently, like this kind of an equation here. What do you got to do first? Got to move your 667 to the other side, right? You got to get your x's on the same side. So if you didn't round, like if you just kept this in your calculator, it's 0.88. Oh, it's 0.889 anyway. 0.889x equals 5.335. And then what? Yeah, by 0.889. Now, because I do this wrong, I'm not doing it wrong at this point in time, but this is a nice number. It's 6. I'd be really happy if it was 6. And every time I'm like, I get these wrong. Why? You guys, this is x. What is it that we need? We need h. We need the horizontal distance. So once you have x, just put it back into one of these two equations for h. I would put it in here because it's simpler, but it doesn't matter. Yeah, it was 8.996, so he's 9 feet from the wall. Nope. Okay, we're going to do number 7. Okay, so number 7. Or skipping 6. So you could do your picture for 7 up here if you want. Okay, so it says to measure the height of a tree. There's my tree. Okay, so it says a surveyor walked a short distance from the tree and found the angle of elevation to be 43.9 degrees. So 43.9 degrees. Then it says he walked 20 feet further and measured the angle of elevation. So 2 triangles here. To be 37.6. Okay, so if we pull the triangles out, we've got this first triangle. I'm looking for the height of the tree, 43.9. And the second triangle, this is 37.6 and the height. Now, We don't have any, we know that part of this is 20, but that doesn't help us at this point. Yes. Yes. So this, we don't know how far he started from the tree, so we're going to call it X. But we do know that he walked 20 further feet. So this is going to be down here, X plus 20. Yep. You got tangent again, because most of these ones are tangent. I have to work hard to get you a question that involves sine or cosine. Okay, now question. This is what you have. Here's your two tangents. Do you want to get X by itself or H by itself? I think H again. You can get, if you try to get X by itself here, you're going to have to distribute first. You can do that. It's just ugly. So it's easiest to get H by itself because H is not going to have this. But it's a little bit easier because how do you get H by itself? Yeah, times by X here, times by X plus 20 here. So it's tangent 43.9. If you don't like that, turn it into a decimal. And then is H. And H over here is X plus 20 times the tangent of 37.6. So tangent 43.9. They're both equal to H, which means they're equal to each other. So 0.96 X equals 37.6. 0.77 times X plus 20. Okay, distribute. So we got 0.19x equals 15.4. So x is 81.06. Once you have one of these, then you just go back up and use the other equation. So I got 78 feet from my tree. So here's what I would like to say. Couple things. You do not have homework today. You can see that. You will have homework. The homework on this tomorrow. I'm not going to be here. I have a doctor's appointment I have to go to in Grand Rapids. So you have a worksheet that you're going to do the whole hour. Okay. So some of them will be this level. Some of them will be easier. Okay. Like fewer of these ones because these are hard. I think it ends up being 7 problems. 78. You got to plug that back in because that's X.
But 80 for X is correct.
81. That could be a rounding potentially.